Okay, so number 5, we have two particles moving along the x-axis. For 0 to 8, the position of particle P is given by x of t, while the velocity of particle Q is given by v of t. Particle Q is at x equals 5 when time is 0. Okay, so first it says, when is particle P moving to the left? So for that, I need Vp of t, right? So first, I want to say, okay, so I say Vp of t is equal to x prime p of t. Get in the habit of writing it this way, right? So if you want to find the velocity, that it equals x prime, or the acceleration equals x double prime. And so the derivative of x of t is an ln, so it's going to be 1 over t squared minus 2t plus 10 times the derivative, so it's 2t minus 2. When you factor, this is 2 times t minus 1 over t squared minus 2t plus 10. Okay, if I want to check when the particle is moving to the left, I need to set Vp of t equal to 0, and that means t is equal to 1, right? And so my time interval is from 0 to 8, and this is t equals 1, right? And so label this as Vp of t, and then you can do your sign chart like this. And you can say, since Vp of t is less than 0 over the interval, well, it's probably more efficient to do it that way. It's probably more efficient to say, here, this, I'm going to erase. What was it? This is particle P. P is moving to the left over the interval 0 to 8, no, to 1. So Vp of t is less than 0 on that interval. Okay, and so important things to watch out for here is that the interval is closed at 0, open at 1, right? And all that stuff. So here, you have 1 point for finding the derivative, and then 1 point for giving the interval. And then B says, find all times t for which the two particles travel in the same direction. So you want Vp of t and Vq of t to have the same sign, right? So Vq of t is equal to t squared minus 8t plus 15. If I set that equal to 0, it's t minus 5, t minus 3. So t is equal to 5, t is equal to 3. And so now what you want to do is this. So you want to compare the two of these. So this was Vp, right? This is 0 and 8, and there was it was 0 at 1, and it's negative and positive, right? And it's 0 here. And then do a similar one for Vq of t, but put in, 3 and 5 like this, right? And so this is positive, negative, positive, and they have the same sign. You can compare vertically from 5 to 8, Okay? Yeah.
Define the composite you put it into the original function?
Into V.
Wait,
V.
why not V? Isn't V the velocity and the other one's the position? So why not?
Yeah, but this is if they're traveling to the left or right. If they're traveling in the same direction, not where they are. Not their position, but which way they're going.
Okay, yeah.
Yeah? Mm-hmm.
Aren't they traveling in the same direction?
Are they?
They're both.
Yeah. 1 to 3 as well. I'm sorry. Yes. So P and Q are traveling in the same direction. Over. So here. And here. Okay? So over the interval 1 to 3 and 5, 8. Because VP and VQ have the same sign. Right? So justify. Huh? Well, it says find all the time, so you really should do some analysis. They give 1 point for the intervals and 1 point for like all of this. Okay. C says, there. C says, find the acceleration of Q at t equals 2. Is the speed of the particle increasing, decreasing, or neither at t equals 2? So for the speed to be increasing, the velocity and the acceleration have to have the same sign, right? So what we want now is we want A Q of t. This is equal to V prime Q of t, and that's equal to 2t minus 8. Okay, we want it at 2, right? So A of 2 is equal to negative 4. So, and that's less than 0. V of 2, label it as AQ. I'll take points off. Two different ones. A at 2 is positive. I'm sorry, V is positive. Right? And so we say A of 2 and VQ of 2 have opposite sign. So that means the speed is decreasing. It's going slow. Okay, D, find the position of the particle Q the first time it changes direction. Well, the first time Q changes direction is at t equals 3 from down here, right? So if I want the position, yeah, I have to do, huh? So I have to do x cubed of 0 plus the integral from 0 to 3 of, what was it that I was given here? VQ of t. And this is, for the velocity, but now you want the position.
Oh, I was looking. I was switching what it said for BP.
This is a no calculator cycle, so this is 5 plus the integral from 0 to 3 of the function e squared minus 8t plus 15 dt. So this is 5 plus t cubed 3 minus 4t squared plus 15t from 0 to 3. And so this is 3 cubed over 3 is 9, minus 36, plus 45, plus 23. Okay. Okay. So this last one was kind of fun. Yeah, so let f be a differentiable function. No, not, wait. No, I don't know if it's differentiable. It's the function. Well, we'll give it the function. Let g be a differentiable function. The table gives values for g prime. Let h be a function whose graph consisting of 5 line segments is shown in the figure above. Okay, find the slope of the line tangent to the graph of f at x equals pi. So the slope is the derivative at x equals pi. So we want the derivative of f at x equals pi. Alright, so for part A, f prime of x is equal to, alright, so there's some chain rule here. So that's going to be negative 2 sine 2x plus e to the sine x cosine x. Right? And then f prime of pi is negative 2 sine of 2 pi, which is 0, plus e to the 0 cosine pi, so that's just negative 1. Okay, so they just want to see if you know what derivative means. And that's just 1 point. This whole thing is 1 point. Okay, B. What does B want? Let K be the function defined by h of f of x. We want K prime of pi. Okay, major chain rule. They want to see chain rule. So if I want K prime of x, that's h prime of f of x times what?
F prime.
F prime of x. And then evaluate it at pi, h prime f of pi times f prime of pi. Alright, f prime of pi, we just found that it was negative 1. And then what's f of pi? I'll do it up here. F of pi is cosine 2 pi plus e to the sine pi. Well, that's e to the 0, that's 1. And what's cosine 2 pi? 1, so that's 2. Right? So this is going to be h prime of times negative 1, huh? Okay, and then what's h prime at 2? Where? Yeah. So h prime at 2, so this is h, this is 2. What's h prime? The slope of that one, h prime. H prime is the slope here, and what's the factor? Negative 1 over 3. So it's negative 1 over 3 times negative 1, 1 over 3. So that's kind of a fun one there. Okay, C. Let m be the function of this. Find m prime of 2. Okay, so m prime of x is g prime of negative 2x times negative 2. I'll put that in the front. Oh, sorry, this is product rule. So I'll do U prime V plus U V prime. And we want this at 2. So this is negative 2 G prime of negative 4 times H of 2 plus G of negative 4 H prime of 2. Oh my god, how fun is this? So negative 2 G prime at negative 4 is negative 1. H of 2. What is H of 2? They H of 2. And that's interesting. They have negative 2/3 in the... Oh, but we can find it, right? We can find it because what's the equation for that part of H of x? What's the equation there? It's y equals negative 1 over 3x, right? So it's negative 2 over 3. Right? That's what they want you to do. Plus g of negative 4 is 5 times h prime of 2. What did we say before? Negative 1 over 3. Oh, how fun is that? That's all negative 3.
This is just like chapter 3 rehashed.
Yeah. And then D, is there a number C in the closed interval from negative 5 to negative 2 such that G prime of C is negative 4? So, such that G prime of C is negative 4. Alright, so what do we know about G? G is differentiable, which means it's what? Which means it's continuous. So, if you see here, what are the values of G prime of x? The values of G prime of x alternate between what and what? Say, the mean value theorem says there has to be a point such that the slope of the secant line equals the slope of the tangent line. So can we find the slope of the secant line from negative 5 to negative 3? Why don't we do that here? So g of negative 5 minus g of negative 3 over negative that's equal to negative 4. Let's see, g of negative 5 is negative 10. No, hang on. What's g of negative 5? G of negative 3. Oh, I did it in the opposite direction, but it's okay. G of negative 3 is 2 over negative 2. That's negative 4. Is that right? So then you say by mean value theorem, there is a point where G prime of C is equal to negative 4. Okay, because that's what the mean value theorem says. The first one, again, it's a rate problem. Water is pumped into a tank at a rate modeled by WT. Water is removed from the tank at a rate modeled by R of T. And for R of T, we have the equation we have a table of values. R is differentiable, it's decreasing, right? So like the values are shown, at the time t equals 0, there are 50,000 liters of water in the tank. So estimate R prime of 2. The derivative is the slope of a table of values. I just have to do, I just have to find the slope. So pick 2 points. So for part A, R prime of 2 is equal to R of 3 minus R of 1 over 3 minus 1. And that's 950 minus 1190 over 2. That's negative 120. Okay. This is R prime. So tell me what minutes this has.
Per hour.
Liters per hour per hour. So R has units of liters per hour. And this has liters per hour. So you can also do liters per hour squared. Use a left Riemann sum with four subintervals indicated in the table to estimate the total amount of water removed from the tank during the 8 hours. So total amount of water removed from the tank. And then again, is this an over or under estimate? So B, this is a left Riemann sum. So you can either say this is LRAM, or you could say, LRAM is actually the, integral or the area, whatever, of R of t dt. Okay? So if you want, how many subintervals? 4 subintervals. So it's going to be 1 times, the left one is 1340, plus 2 times 1190, plus 3 times 950, plus 2 times 740. That's 8,050. So now, R prime, so look here. R has units of liters per hour. Times dt, t is hours. Liters per hour times hour, that's liters. That makes sense. And so the question says, is this an overestimate or an underestimate? Overestimate. Since R of t is decreasing over the interval 0 to 8. Use your answer from part B to find an estimate for the total amount of water in the tank to the nearest liter at the end of 8 hours. So some is being pumped in, some is leaving. This is how much is being removed. We just found how much was being removed in the whole time. And now what we need to do, we need to figure out how much came in, right? So C is, okay, so first, total amount of water is, at the very beginning, how much was there? 50,000 liters. Plus, we added some. Well, how much did we add? Well, that's the interval from 0 to 8 of Wt dt minus how much did we subtract from 0 to 8 R of t dt. So this is 50,000. The second one, that's enough, that you just write that, and then you can plug it into the calculator. So that's plus 7,836.195 minus what we just got from above. And so now there's 49,786 liters. Okay, as far as writing and showing your work, is concerned. So first of all, in the top here, you get 1 point here, like for the whole process with the correct answer, and 1 point for units. For part 2, there is 1 point for the correct Riemann sum with the whole thing. 1 point for the answer, and then 1 point for seeing it's an overestimate. Here, you get 1 point for showing the integral, and then 1 point for the answer. So it's also okay if you were to write 50,000 plus integral minus 8,050 in one step and then plug it in. Okay? Yeah.
Is it R0 and something?
Yeah. Mm-hmm. And then D, what does D say? Is there a time when the rate at which the water is pumped into the tank is the same as the rate at which water is removed from the tank? So what does that mean? Well, yeah, so we want W of t to be equal to R of t, right? That means W of t minus R of t has to be 0. Okay? Okay. So let's see how we're going to do this one. So what we need to consider is this. Okay? We need to consider that quantity, W minus R, is at some point 0. Now, one way to show that, because both of these functions are continuous, so is the difference. So if I could just show that there was a time where this quantity was positive, and there was a time where this quantity was negative, if this is a continuous function, to go between positive and negative, it's got to cross the x-axis, right? So that's what I have to show. So let's see this. When t is equal to 0, let's just look at endpoints, right? W of 0 was what? It's 2,000. You can plug that in. Okay? R of 0 is what? 1340. Okay? So therefore, W of 0 minus R of 0. No, that's not R of 0. Oh, that's not R of 0? No, that's not. R is how much is being pumped out. That is some other variable, but not in that variable. W of 0 minus R of 0 here is positive, not equal to positive. Okay? So, at the other endpoint, when t is 8, W of 8 is 81.524. You plug that in the calculator. R of 8, you get it from the chart, it's 700. So, W of 8 minus R of 8 is less than 0, right? Okay? Well, because there is a sign switch, right? Because it goes from positive to negative, you say, therefore, since you have to say that it's continuous, Wt minus R of t is continuous. There is a point where Wt minus R of t is equal to 0. And we already established that that means that they're equal, so we're good to go. Okay? You have a particle along the line. The velocity is given. It's a cute little sign equation. And we're given the position. Okay, so this one was interesting again, and I'll tell you why. So, for part A, is the particle speeding up or slowing down? And A, so what do we need to look for?
On what their sign.
Yeah, so we want V of 4. This is a calculator problem, right? So you just plug it in. And that's 2.979, and you just say that's greater than 0. The best way to do these is you put this into the right, like into you graphing portion, right? You graph it, and then that way, if you want to plug it in, let's say F1 of 4, and so on. And then A of 4, you don't have to find the derivative, you just do numerical derivative, right? A of 4 is negative 1.164, and that's less than 0. And then you say, because V of 4, and so now look, here I didn't write that this was V prime, right? So what I say is, I'm not going to erase or whatever, so I can also say, and A of 4, which is V prime of 4, okay? Because V of 4 and this have opposite sign, particle is, what is it doing? Slowing down. Okay.
I already, if I look at it, that A of 4 is that
That's fine. Find all times when the particle changes direction, justify your answer. So it's enough here to do, like V prime and then like a number line, a sign line. So let's, I'm sorry, okay, I'll tell you. So V of t, is equal to the calculator part. You don't have to write much down. At t equals 2.707.
We do this by graphing.
Yeah.
Wait, so you plug V of t into the calculator?
Yeah.
And cross the x-axis at 2.07.
Yeah. And so this whole thing is happening from 0 to 3. And so 2.7 is somewhere here. And then you see also visually that it's positive here and negative here. It says, okay, so first of all, this is, not useful at all, right? So what I want to do is go to menu, window settings. We know that X max can be 0. And in the whole course of this problem, we're between 0 and 3, right? So why don't I go to 3 here? And let me just see how that looks. That's how that looks. Okay? Now, for part A, I wanted, like V of 4 and then the derivative, right? So for V of 4, I could have just done, let's say, menu, trace, graph trace, type in 4, enter, and it gives me the value. I could also do control, add a page, add a calculator, and do F1 of 4. Just make sure you're in radian when you cross over from the graph to here. And that's the same value. Yay. And then here I could do menu, calculus, numerical derivative at a point, at 4, first derivative, sure. And then here I want f1, right? Oh, sorry, f1 of x. Okay, fine. See, I just went back and put back, and then of x. Okay? And that's what we have. Now for part B, it's asking find all times from 0 to 3 where the particle changes direction. Well, first we have to see where v is equal to 0. And so here, from 0 to 3, so I go to menu, window, not window, analyze graph, 0. Okay, so here, that's one point between 0 and 3 where b is equal to 0. And that's 2.7047. So now, I go here, right, it's 2.707. And then you can see visually that right before that point it's positive, right after that point is negative, so that's where we're at. Okay? And I say here, since v of t changes from positive to negative at t equals 2.707, particle changes direction at that point. I'm abbreviating, but you will not. Okay? Yes, yes, you have to say that it's because it changes sign there. So, okay, this is an important point. Students, AP readers, like when I'm at conferences, they always stress this point. They say the sign chart strengthens your argument, but it cannot solely be your justification. You have to have the sign chart, but then in English, with words and letters and stuff, you have to actually say what that is. Okay? So you have to show this, and then you have to say since there is a sign change, or since it changes from positive to negative, blah, blah, blah. Okay, C, find the position of the particle at time t equals 0. Okay, so this is why I was saying this is an interesting problem. So we want x of 0. What are we given? We're given that at t, no, not there. We're given that at t equals 4, x is equal to 2. Okay? So here we're going to write first x of 4 plus, now I want x of 0. So my integral has to go from my initial point to what I'm finding, from 4 to 0. So again, this is not the third time so far that we've seen this where you have the reverse interval, right? From 4 to 0, v of t dt. So this is 2 minus from 0 to 4, v of t d. And so when I go here, okay, I can do the whole thing in here. I can do 2 minus interval from 0 tab to 4 tab in f1 of x dx.
Why do you add d2? Why do you add c?
The 2, that's the starting position. Huh?
No, it's not add.
Even though, yeah.
So that's just like the they give us. They say, well, is that okay? Backwards from that.
You work backwards from that. So hang on, this is negative 3.815. Okay, so here's why we're doing this. We want, what is the question asked? The position at time t equals 0, right? The position at time t equals 0. What is this integral? What is
That's the
the displacement? The integral is the displacement. It's how much it moved, right? It's how much it moved, and then we're like to the point like that. So basically, look at how it works. If you want to think about it, this is x of 0, right? Now, rearrange this. Rearrange this. X of 0 is the initial position, where it started when the world began. Then, what is this interval? It's how much it got displaced, how much it moved. So this is a negative, right? Add it to here, and then this is the position at x equals 4. So look at this. This is initial position, final position, and displacement. If you rearrange the interval, and if you bring the interval here, then what do you have? The initial position plus the displacement equals the final position. Does that make sense to you? Yes, it does. If you rearrange it, you get x of 0 plus the integral equals the final position. You see that? We're just working backwards. Because this is x of 0, this is x of 4, and this is the displacement between 0 and 4. You see that? So the integral, when we do it that way, we kind of work backwards. It's like rewinding the video. Okay? That's so cool the way that works. So part D, it wants the total distance. And that's the interval from 0 to 3 of the actual value of v of t dt. That's all you have to show. And then when you come here, it's up to you what you want to do. You could also, like, you could just, like, are you guys used to selecting? If you're, get used to how to do that. Select it, and then you can do Control C. Right? So now, you can come here. And then you can do interval from 0 to, what was it, 3, tag, absolute value, that's also here, and I didn't take it, absolute value, okay, then I do Control V, right, dx. And that's the speed, that's the distance that it traveled. Okay,